So let's pretend we had some random function like this. Then we had a peak here. Then we had a valley over here. Then it kept on going forever. Okay. Now we've kind of mentioned already, we said that if we go left to right, picture like a little car driving up, we have increasing up until a peak. Once we get here though, we have a maximum. This would be a local max or an extrema. So at this point, the slopes are all positive. If you took a derivative of this function, call it just some f. If you plugged in these values into f prime, you get positives the whole way. And then at this point, you get a 0, which is the critical numbers we talked about last time. Right after, you would get negative slopes up until we got to this, right down here would be going down again. So all the derivatives at these points would be negative. And then here we'd have another 0, which would be a critical number. Then after we have positive derivatives. So in essence, this idea is how you use the first derivative to tell you if it's a minimum or a maximum. So you first find your critical number, and then you plug into the derivative before and after. And if it's negative and then positive, see how it goes from plus to minus, then that means you have a maximum. If it goes from minus, right, minus to plus, because right here we'd have minus, and then suddenly plus, after the critical, then you have a minimum. So in this section, we're going to find the critical numbers and then test around them to see if we have a local max or local minimum. Okay, so that's the big picture. And then they're going to ask us, where are we decreasing, where are we increasing? Does that make sense? So first, we're going to start off with just figuring out where are we increasing and decreasing. That's it. Identify the open intervals on which the function is increasing and decreasing. Then you find the function. Okay, so this is the function we want to know. Okay, you can graph it and see it, but that's not the point. We want to use these techniques and concepts. Techniques and concepts in order to find maximum and minimums or intervals of increasing and decreasing. So step one, like we did last time, find the derivative. Find f prime of x. So basically the derivative, I'm going to skip that step. If you have a question about it, let me know. It's going to be this. Step two, find the critical numbers. By setting did I miss the T there? By setting f prime of x to 0. This guy, yeah, you could factor that. That's true. Those would help you find zeros of the original function if they ask for them, like the little intersections. Set this to 0. We get 2x equal to 6, x equals to 3. So here's your critical number. Running out of space here. Go ahead.
How do you get 2x minus 6?
You do the power rule on the first one.
Yes.
So what's the derivative of x squared?
2x.
That's where this comes from. Derivative of negative 6x is this guy. Derivative of 16 is 0.
Okay.
So just do a regular derivative on the original. Set that derivative to 0. Solve for x. That's the first 2 steps.
Thank you.
Step 3. You use the first derivative test to test around the critical numbers. Oops, space here. To determine if it is a max / minimum and to find the intervals of increasing / decreasing. So you can find both at the same time. So do on the next page. So far, you guys still with me?
Yes.
Okay. So you can test any point before and after the critical, it doesn't matter. So I'm going to draw a little line here. Put 3 in the middle, that's my special number, critical number. I'm going to choose 4, I guess, and 0 just because it's easy. So test around it and find out what's going on. So f prime of 0 is equal to 2 times, that's 2x, right? Yeah. Minus 6, which is -6. So I'm negative over here. Now test a point after. You get 8 minus 6, which is positive, plus. So basically this is decreasing all the way until we get to the critical number. Then we begin to increase. Does that make sense?
Yes.
So all we have to say now is we're increasing from, they want to know the interval, right? increasing from 3 to infinity. So right after 3, we start going up again. Decreasing before 3. So negative infinity all the way until 3. So knowing that this is happening, decreasing and then increasing, can you tell this is a maximum or a minimum?
A minimum?
Yeah, this is minimum, right? Because it has that shape.
Yes.
So if it's minus and then plus, going down then up, minimum. If it was positive and then negative, it would be max.
So it's because it goes from negative to positive, right?
Right. So we have a minimum at 3 comma something. I don't know what that something is. So we got to find it. So in order to find the corresponding value, you got to plug it into 3. The original question was x squared minus 6 times 3 minus 16. So this will be negative 25. Got it over there. So at 3 negative 25, we have a minimum. Okay. So let me show you the graph. All this could have been seen on the graph real easily. Again, the point is to apply the derivative to something specific. Can you guys see the graph here?
Yes, Professor.
So here's the minimum. So as you can see, right? Let me see where my little thingamajigs. From left to right, we're going down. Right, all the way down. Then right after this, we start going up. So that's what we show the first derivative test. So visually, we can obviously see that we have a minimum down here, right? But you can prove it without graphing it. And this theory also applies to like higher dimensions, not just 2D graphs, to find minimal and maximum points. Are there any questions on what we just did?
How can you find if we don't see the graph?
What we just did, this, right? We test before the critical number and after, and then we'll know that we have a minimum at the critical point. So I want you to do it this way, obviously. The graph is just so you can see, put it all together, like visualize it. Damn, there's a mosquito biting me. Okay. Any questions on the first example?
No questions.
All right, let's do another one. Okay. given this function x squared minus 4x. Part A, this time I'll separate them into different questions. Find the critical point or critical numbers of f. So step one was take the derivative. What is the derivative of f?
Two x minus 4.
So now set it to 0 to find the numbers. So 2x minus 4 equals 0. 2x equals 4. X is equal to 2. Okay. Part B, find the intervals for increasing / decreasing. So just test around. So once you have the critical number, test before it and test after. My special number. Okay, so just plug these numbers into the derivative and see if it's negative. Okay. So f prime of, I guess I'll write it again. There's a derivative function. So the derivative at 0 is -4. The derivative at 3 is equal to 2 times 3 is 6 minus 4, 2. So minus positive minus positive. Okay. So what are the intervals for increasing?
For increasing,
Mhm.
it's from 3 to positive infinity.
Pretty close. It's going to be right after the minimum.
So it's 2 positive less than I. I'm
Mhm.
sorry, I said that in my own language, infinity.
That's okay. Because at this point, there's a change in, how should I say that?
So we start from the where it start increasing, right?
Mhm.
Oh,
So right after it, where you begin to increase. Because here we're at 0, and before we're decreasing.
oh.
Decreasing will be negative infinity until that critical number. Any questions on finding the critical number and then testing around it to find the intervals? Okay. Part C. We'll apply the first derivative test. To find the maximum minimum. So what do we have? Minimum or maximum?
A minimum?
Yeah, we have a minimum, so minimum will be at 2 comma, plug in 2, that'll be 4 minus 8 negatives. Wait, yeah. So since we already did most of the work to find the intervals, we can kind of figure this part out. The y value you'd have to plug it in to find, but you'll know it's a minimum at the critical number with all the info so far.
So if you have the critical number, you would plug that into the original function and find the -4. Why?
Right, you plug it in, so you would get 2 squared minus 4 times 2, which is 4 minus 8, which is -4.
Okay.
Okay. I think the first few questions don't ask for everything. They might just ask for this part, but I want to go ahead and do everything for each question. That way, you can just do both parts whenever.
There are 2 questions in the 4.3 assignment that I don't know.
Okay, let me look it up.
Can we go over that at the end of the class if you are doing the other one now?
Let me see. Hold on. Which one gave you trouble?
It was the sine of x -6, and there were interval given to us from 0 to pi, something like this.
Oh, okay. Yeah, we can do it real quick. Define the increasing, decreasing intervals of f of x equals sine x minus 7.
It was 6, I guess.
Yeah, we can do yours, that's fine. Minus 7.
Thank you.
The derivative will be cosine x, right? The first step is find the derivative. This is number 1. Number 2 is you set it to 0. We got to put the little interval here. Okay, so cosine is 0 at x equal to pi over 2, and 3 pi over 2 from the unit circle. So then test around these numbers. Okay.
So we have to find the cosine of x from the unit circle, right?
You have to find out when it's 0 from the unit circle. Yeah, the angles that make it 0 is from the circle.
Okay.
Okay. So these are the critical ones. I'm gonna use pi as a test value and pi over 3 is another one. So cosine of pi over 3, what is that gonna be?
One half.
So positive, right? Cosine of pi, thanks, man. Gonna be negative, correct? So we have 2 pi would be positive. Yeah, I guess it could. So we have plus, minus, plus. Right? So where are we increasing?
From negative infinity to pi.
Well, up to pi over 2, right? Because
Yes.
the only thing is they told us to stay 0 to 2 pi, so we have to put 0 as the lowest one.
So it would be from negative infinity to pi over 2.
It'd be 0 to pi over 2 because of the restriction they gave us.
Oh yes. I'm sorry.
Then we're increasing again, right? After 3 pi over 2.
So it's 3 pi over 2 to 2 pi, right?
Yeah. And we're decreasing from pi over 2 to 3 pi over 2. Any questions on number 3 here? If they would have asked for the minimums and maximums, you would have said minimum here pi over 2 and sorry, maximum at pi over 2 and minimum at 3 pi over 2.
Okay.
I think, for example, later in the homework, because I didn't the beginning doesn't make you do everything. I've been doing everything just because it's coming anyway. But check out number 7, right? So we did something like this. We found the critical numbers first by taking the derivative, setting it to 0. We test around those numbers that we find, or maybe just one number, and check out where it's increasing and decreasing. And then based on this information, you can determine where your minimums and maximums are. Since this is a quadratic, you should know if it's negative here, it's opening down, so we should have a max. So there's no minimum. This is a cubic. This might have multiple relative minimums or maximums, but it's going to be the exact same stuff. Any questions on the main idea? Does that make sense?
Yes.
Okay. That's all you got to do. Apply the concept of derivative. We've been doing that all semester, right? Derivatives tell you about slope. So use the implications of slope to tell you what's going on at specific spots. Alrighty. Now let's go ahead and talk about 4.4. You can get a little ahead. You guys have no questions on 4.3? I think I'll probably have to start another page. Yeah. Yeah, this is blank page instead. This is so blurry. Weird. Okay. So 4.4 is using the second derivative as a tool. Second derivative will tell you about concavity. First derivative told us about increasing, decreasing, and maximum minimums. But concavity can also tell you about maximum minimums as well. So this is a good test when you don't want to, like, let's say you want to just plug in your critical number and determine, is it a max or not? So you can just plug in the second derivative. If it is positive, it would open up, which means minimum. If it's negative, then it is opening down, which is maximum. The only thing is, if finding the second derivative is a pain, then maybe just use the first derivative test instead. Does that make sense? Like, if it doesn't force you to do one way or the other. Here we go. Example 1. So given f of x equal to x squared minus 2x plus 8. Now, we probably already know the answer. That's not the point, right? Stupid thing. We know that this is going to be a minimum. You see that?
What does conservative means?
Oh, yeah. Let me give you a picture. Did you guys see the graph?
Yes.
Okay, so this function, this parabola, is concave up everywhere because it's opening upward. So if it's
Yes.
opening up, it is considered to be concave up at this value, but also pretty much the entire thing is concave up. Now, this guy is different. We have concave down. See how it's opening down before the 0?
Yes.
We zoom in a little bit, you can see it better. So on the left side, it'll be concave down. On the right side, we'll have concave up. So it's opening upward. That's what we mean by concavity.
Okay.
Some calculus books might call it I think they have another word for it. It's concave and convex. It's just the same thing. Same thing. Convex, I think, is just the opposite. But I prefer to say up and down. It's simple.
Okay. Thank you.
So what we're gonna do is use the second derivative, find the critical number, use the second derivative on that number to find out if it's concave up or down. If it's up, then it's minimum. If it's down, then it's maximum. That's it. That's the goal. That's all the second derivative test does, to be honest. Okay. Determine the intervals for concave up and concave down. Okay. We probably already know the answer because we know the shape, but let's just pretend we don't. So step 1, find f prime, which will be this, right? Step 2, set f prime to 0 to find the critical number. We'll just call it crit. All right. 2x minus 2 is equal to 0. 2x is equal to 2. X is equal to 1. Critical number at x equal to 1. Step 3, find f double prime. So that would simply be positive 2, correct?
how does double prime work?
Just take another derivative. So you take one to get this one, take a derivative of this to get the second.
Okay.
So this is the second derivative of the original function because I did it 2 times.
So you did it 2 times and then add them together. That's how it's done.
No, just took a derivative 1 time, right? Let's go through it. What is the derivative of x squared minus 2x plus 8?
2x minus 2,
What is the derivative of 2x minus 2?
1.
It's gonna be 2.
Okay. Yes. Yes, I got it. Because negative 2 is 0 and then derivative of 2 is 2x is 2. Okay.
Exactly. Yeah.
Got it. Thank you.
Okay, so now this means something conceptually. Because if let me write a note here. If let me write this out in English. If the second derivative is positive at a critical number, then it is concave up. Yes. This implies a minimum at a critical number. If the second derivative is negative, 1 second, sorry. If the second derivative is negative, then add a critical number, then it is concave down. This implies a maximum. Not the critical number. So knowing this information, we got a positive number for the second derivative. What does that mean?
Concave up.
Yeah, it's concave up for sure, right? But also there's nothing to plug. I can't plug in anything So it's always 2 for any x. So that means it's concave up for any x. Because it's just a parabola opening up.
Yes.
So we would just say it's concave up. All the time. Concave down is nowhere.
So we put D and E if you have question and homework, right?
Yeah, I think it's D and E or undefined. I forget what they say.
Okay.
One of those. Any questions on number 1?
So if the second derivative, the second prime
Mhm.
was a 4, would it be concave up the same thing?
If it was, I'm sorry, one more time.
So for the step 3, we said find the second derivative, which is equal to 2, right? And
Yes.
you said it's concave up from negative infinity to positive infinity, right? So if the second derivative was not 2, it was something else, it could be any number, would it be the same
Yeah,
or
so in the
different?
next example, we're gonna have to test around the critical, just like how we did the first derivative test.
Okay.
That way we can see, okay, what's going on. Here, since it was just a positive number, there was nothing to test because it's always concave up everywhere.
Okay.
But yeah, let's do the next one. I'll show you how that works. Any other questions though, before I move on? Okay, cool. Number 2. One second. Okay. So step 1. Find f prime. So f prime will be, you guys agree with that?
Yes.
Step 2. Find f double prime. Okay. Step 3. Set second derivative equal to 0 to find the inflection point. Okay, so 6x plus 6 equals 0. Solve for x. X is 1. This is the inflection point. And inflection point means where the graph changes concavity. So it goes from concave down to up or up to down. And we'll graph it after we're done, we'll graph it and I'll show you. Okay. So we got a test. So step 4. Well, actually, x be 0. For this one, well, you would subtract the 6 to get this, and then you would divide both sides by -6. So it should be 1. And 6 is 0. Yeah.
Yes, it's 1.
No, it's okay. No, I feel you. So test around x equals 1 with the second derivative in order to figure out where we concave up or down. Okay, so I'm going to choose 0 and 2. So second derivative at 0 is going to be -6 times 0 plus 6, which equals to 6. So concave, wait, hold on a second.
I think it's up because it's positive.
Yeah, yeah. Concave up. Second derivative at 2 would be -6 times 2 plus 6, which is -12 plus 6, right? Concave down. Okay, so let me write something to help you remember. But just real quick. If it's positive, concave up, right? Happy face. If it's a negative, sad face. So we got a positive, concave up, negative, concave down. This implies if this is a critical number, you would say, oh yeah, that's a minimum, maximum. But it didn't ask for any of that. So we would say the concave's location, concave up, would be negative infinity all the way until the inflection point. Concave down after the inflection point and beyond. Does that make sense?
Yes.
So let's go ahead and graph it so you can see the original function. Give me a second. Yeah. Here we go. Can you guys see the graph?
Yes, Professor.
Okay, so inflection point was at kind of around here, at 1 actually. There it is. So here's the inflection point. So before that, we are opening upward, right? That's what we found with the second derivative. After we're opening down, so concave up before 1, negative infinity to 1, concave down from 1 to infinity. And so we, yeah, go ahead.
So the concave down was from 1 to positive infinity. Because it was down, isn't that like going through the negative y-axis? Wouldn't that be negative?
What do you mean let me put the graph back.
Oh, I'm sorry. I got it now. Okay.
Oh, okay.
Got it.
Yeah, just remember it's just like, is it opening upward or is it opening down? But that specific spot where it changes is hard to see, so you have to find the inflection point with the second derivative.
Yes, I got it now.
Okay, let's do one more and we'll call it a night, because I know it's getting late. And we can only process so much in a session anyway. Okay, 3. So on this one, Use the second derivative test. To find. No, it does, man. You're right. Visualizing it, putting it all together. So it's important. Using the second derivative test to find the relative extrema of f of x equal to x to the 4 minus 4x. I don't have space. Damn it. Okay. So here we're going to use a second derivative test to find the local mins and maxes, which means we're going to need the critical numbers.
Why is there two functions?
Oh, I just couldn't fit it in there. Just one. Okay, so step 1. Find the critical number so we got to find the derivative and set it to 0, just like before. Factor GCF here, we got 4x squared, giving us x minus 3. So 4x squared equals 0, x minus 3 equals 0. Critical numbers are right here. All right. So we did that a bunch of times already. Step 2. Find the second derivative. Second derivative will be 12x squared minus 24x. Step 3. Plug in the critical numbers into the second derivative. That will tell us if it's their minimums or maximums. Cool. F double prime of 0 is 0. F double prime of 3 is 12 times 3 squared minus 24 times 3. 36. So if it's positive, that means concave up, right?
Yes.
So that means we have a minimum at 3 comma something. I don't know what that other number is. We do not have a maximum. But to find the y, right, you'd have to plug it in to here. after you do all the work, you end up with this. I don't feel like doing it. I wrote it down earlier somewhere. Pretty sure it's -20. Doesn't matter though. Okay, so that's the whole point. You use the second derivative to make it easy to find minimum or maximum. See how we don't have to test around stuff like the first derivative test? So this one's easier only if finding the double prime is simple. If finding this is not simple, then first derivative test is probably better. What does this mean again? We got one of the criticals gave us a 0. 0 is neither positive nor negative. I guess you could argue it's both, but it's an inflection point, right? Okay, so let's graph it and see what the heck's going on. So we have a minimum right there. Actually, turns out to be the minimum, a global minimum. We have an inflection point at 0. Here. The inflection there. Minimum here. So we are concave up before this section. Looks like we're concave down in the middle and then concave up again. But they didn't ask about that. But it's kind of hard to tell on this one. We only see one inflection point, so I would say concave up after at 3 we got maximum. So yeah, concave up after and before, but in between there's something going on. We would probably have to look into it deeper, but anyway. Is there any questions on finding the minimums using second derivative? Minimums or maximums if they existed?
No questions from my side.
Alrighty, cool. So we'll stop here. You guys have any questions or concerns about the homework or class in general? You guys doing all right?
In the 4.3,
Uh-huh.
I don't know what values are given on your end, but on my end it's h of x equals cosine of 3x over 2, and the intervals are from 0 to 2 pi. I'm just confused with this one.
Oh, let me log in. Which problem? Which section?
4.3, question number 4.
Okay, and you guys does anyone need more while I'm here? Does any more time on any of the older sections?
Yes.
Okay. All right, I'll do that for you guys. I'll open up chapter 3 one more time here. And 4 should still be open for a while. Okay. Go ahead and move them all to the 30th. The first is fine. I know some of these sections can take a while, so especially chapter 3, there's just a lot of steps on those derivatives. Chapter 4 starts chill, but the last couple of sections are long too, so don't fall behind. All right, what's the problem were you asking about? I'm sorry.
It was the number 4,
4.1?
4.3.
4.3. I don't feel bad, man. I used to spend like 10 hours every day on this stuff. When I first took Cal 1, it took me forever.
I know. Well, I spend a lot of time doing one question. That's why I don't get the assignments on time.
Yeah. No, it's
I
none of
don't go to another question until I do the first one, so that's my problem.
well, that's fine because I mean they get harder anyway, right?
I know.
All right, so 4.3 you said. What number?
Number 4, but can you do the values that I have for the question?
Yeah, that's fine. It's going to be the exact same thing as 3, but we can do it. The only difference is you have a chain rule.
It's the increasing and decreasing. That's the thing.
Yeah, you're just asking for increasing and decreasing. So you're going to test around the critical numbers, and that's it. So you're going to find 4, 4.1.
It was 4.3.
Oh yeah.
It's blurry, Professor.
Oh, sorry. Okay, so first derivative is going to be negative sine of 3x over 2 times the derivative of the inside, which will be 3 over 2. So this becomes negative 3 over 2 sine of 3x over 2. I'm sorry, what were your numbers?
It's the same.
Oh, it is? Okay.
Yes.
All right, so set this to 0 to find the critical numbers and then test around them. So negative 3 over 2 sine of 3x over 2. Let's divide by negative 3 over 2. All right, when is this going to be 0? This is kind of like a pre-cal question now. So basically, this is going to be 0 whenever the inside is equal to 0 or 2 pi. No, pi. This is between here.
Yes.
Yes. Hmm. So here is an easy one. Divide times 2 divided by 3, x would be 2 pi over 3 times 2 divided by 3. This will be 4 pi over 3. Okay. So these are the critical numbers. So we must test around them. Okay. So let's pick I don't know, easy numbers. Is pi less than 2 pi thirds? I want to say no. Pi is 2/3, so pi would be here. 2 pi is there, I believe. Yeah. Those are the easy ones. Hmm. 3 pi over 4. No, pi over 2 would be good. No, you can pick whatever you want. I'm just trying to pick stuff that's easy on the circle. Um, you could plug in decimals that are in between, right? You could say, what is 2 pi divided by 3? You get some number, plug in some decimal below that, because all we care about is the sign. I'm just being fancy. It doesn't matter. Okay.
Yes.
So you don't have to choose these. I just chose the best ones. That is not necessary.
Okay.
Sign of plug this guy in. Oops. Into the derivative of a 3 pi over 4. Three pi over 4. What is sine going to be at that location? I know this one would be -1. So positive at pi. 2 pi would be equal to this, which would be -1 times 0. Oh, what's that? Pi, 2 pi. Yeah, that's not helpful. I know the number 6 right here, right? So use 6. Who cares? Three times 6 over 2, it's going to be 9. Calculator time. What is negative sine of 9? That is a negative. So positive. I don't care what that is, but we have a plus over here. Plus there. Sine of 3 power 4. Negative. Okay. So now I think we can answer the question. We're going to be increasing from, let's see. We can't go beyond 2 pi. So we would for sure say there's a mistake in here. I don't think this one is plus. Is 6 a bigger than 4 pi thirds? I don't think it is. Yeah, I guess so. Weird. Yeah, this point. Oh, all right. The derivative had a -3/2 in front. Not just a negative. But I don't think that should matter all that much. Derivative of cosine is negative sine. Well, let's graph the thing. It's a weird question.
I know.
That's okay. You won't have anything like this on the test. It's more of a this is a homework question. All right. I need to shrink this down. All right. And they wanted us to look at 0, right? And 2 pi. So within here, 4 pi thirds with one critical number, 2 pi thirds with another one, and 0, obviously. So we should be decreasing from here to here, increasing there, but they have decreasing after 4 pi thirds. Wonder if 6, no, 6 should have been. So the derivative of g, we got negative 3 over 2 sine of 3x over 2. G of 5 is negative. G of 6 is negative. Yeah, I don't know where the hell I got that plus from. Huh. Oh, I see. I'm just fucking tired to it. 6 should be. Let me fix this. Okay. So we almost had it. It's just I messed up right there. So we're going to be increasing from 2 pi over 3 to 4 pi thirds, decreasing from 0 to 2 pi thirds, and 4 pi thirds to 2 pi.
That's the final answer, right?
Mhm.
Thank you so much.
That's all. All right, let me see. I think I already increased the time, right? Yeah, I believe they already extended, correct?
Yes, I saw it.
Let me take roll and then we'll call it a night.